For each of the methods, you don't have to know all the different factoring methods you may have seen in class. Here are my recommendations though. For x factor, you can use that when a equals 1 and the factor pair can be found easily. The formulas for the special cases like difference of sums of cubes and squares, you'll use that when the binomial has either a cube or a perfect square for each of the two terms of the binomial. For slide and divide, use that for all quadratics with rational factors, or you can use Xbox method. For grouping, you'll use those with polynomials with 4 terms. U-substitution for trinomials in the form ax to the 2 times n power plus b times x to the nth power plus c, where these two exponents, one of them is double of the other one. And then use graphing for any polynomial with an integer factor, or if you're able to easily convert the decimal to a fraction. And then the low method would be used for unfactorable non-rational factors. Fall 2020 Test 3 Review, Algebra 2. This test is all about factoring, and we'll go through many of the methods that I put above this page. Number 1, factor 3m to the 6th power minus 33m to the 5th power plus 54m to the 4th power. The first thing we want to do here is factor out the GCF, the greatest common factor. So to do that, let's go ahead and set up our trinomial. Okay, it looks like a number we can pull out of all 3 of these terms is a 3. So let's divide each term by 3. So then we have m to the 6th power minus 11m to the 5th power plus 18m to the 4th power. Besides 1, it looks like there's no other numbers we can factor out, so now we'll look at the variables. We can factor out m. The smallest exponent m is not 6, not 5, but 4, so we'll take out 4 of those. M to the 4th power. So we'll divide each of these terms by m to the 4th power. So 6 minus 4 is 2, so we have m squared minus 11m to the 1st power plus 18, and there's no more m's. They canceled out. So your GCF is 3m to the 4th power, and this is what's left over in the parentheses. From here, we'll try to factor this trinomial further. Identify a, b, and c. Your coefficient of m squared is 1 because there's no visible number there, but there's a variable. For b, your coefficient is negative 11, and for c, our constant, we have 18. Since a is 1, we'll use the x factor method to factor this. So a times c goes at the top, our product is 18. Our sum is b, that's negative 11. We will find 2 factors that multiply to give you 18, and they add to give you negative 11. Negative 9 and negative 2 work in this situation. Now, if you couldn't find that right away, you could always draw a t-chart to find your product and your sum. So the factors of 18 is 1 and 18, 2 and 9, 3 and 6. And they need to be negative because our sum needs to be a negative number. But they have to both be negative because the product is a positive. And negative times a negative is a positive. So we'll write our sums. We have negative 19. That doesn't work. We have negative 11. That does work. and then we have -9. That also doesn't work. So that's why we would choose this factor pair over the others. So from there, we can factor that out. m minus 9 times m minus 2. Okay, we factored the trinomial, and then we can write out our GCF at the front. 3m to the 4th power times m minus 9 times m minus 2. And that would be your factored form. Number 2. Solve x squared minus 3x equals 40. The first step is that we want all the terms on one side and then 0 on the other. Notice your c term, your constant's on the wrong side. And that is putting it in standard form. So we're going to subtract 40 from each side of the equation, from each expression. And then we'll rewrite it in our standard form. X squared minus 3x minus 40 equals 0. From there, let's identify A, B, and C. There's one other step that you could do, is find the GCF. We could skip that step since the greatest common factor is just 1. So from there we have A equals 1, our coefficient is 1. Our coefficient for the middle term is -3, and our coefficient for the constant is -40. From there you're going to choose a method for factoring to factor this trinomial. Since A is 1, it looks like we could use the x factor method. So we'll draw an x. A times c is our product. -40 times 1 is -40. Our b is our sum, -3. We find two numbers that multiply to give you -40 and add to give you -3. If you got -8 and 5, those would be the factors. -8 times 5 is -40, and -8 plus 5 is -3. Again, if you couldn't find that right away, you could draw your t-chart with your factors and sums. So if you write your t-chart, you can write out the factors of -40 and find the sum of each. Keep finding factor pairs and sums until you get the desired sum, -3. That's why -8 and plus 5 works. So from here you'll write out your factors. So we have parentheses x minus 8 times x plus 5 equals 0. Using the 0 product property, we'll set each factor equal to 0 individually. X minus 8 equals 0, and x plus 5 equals 0. Okay, so from there you can solve for x for both. Add 8. We have x equals 8, and subtract 5, and x equals -5. So your roots are, your zeros are -5 and 8. Those are your zeros. Those are your roots, your solutions. Number 3. Factor x squared plus 8x minus 48. First, we want to see if there's a GCF. The greatest common factor is only 1 there, so we can skip that step. Next, we want to choose a factoring method that works here. Let's identify A, B, and C to see what would be a good method. So a would be 1. That's our coefficient of x squared. Our coefficient of the x term is positive 8. And our constant term, c, is negative 48. Since a equals 1 here, we'll use the x factor method. Our product, a times c, 1 times negative 48, is negative 48. That's our AC, that's our product. Our sum, B, is 8. So we will find two factors that multiply to negative 48 and add to 8. Let's draw a T-chart. So our products, our factor pairs of negative 48, and our sum needs to be 8. So the factors of negative 48 is negative 1, 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. 7 doesn't work, and 8 is already used, so we're done with listing out the factor pairs. Find our sums. We have 47, that doesn't work. We have 22, that's not 8 either. 13, 8, looks like this one works, but let's find the last one just in case. 2. So it looks like our factors that we want to use is 12 and negative 4. And we could check that. 12 times negative 4 is negative 48. 12 minus 4 is 8. So that works. From there we'll write out our factors. X plus 12 times x minus 4. And there's nothing else we need to do here, so this would be our factored form. That's our answer. Number 4. Factor 3x squared plus 23x plus 14. Describe the steps algebraically and verbally. Step 1. See if you can factor out a GCF, a greatest common factor. Now, the GCF is only 1, so we don't have to factor out GCF. So we can skip to step 2. Identify A, B, and C. So our A coefficient is 3, our B coefficient is 23, and our C coefficient is 14. From there you want to identify a factoring method and factor completely. Now A is not 1, so we can't do X factor. It's not formula 1 because for 1 this isn't a binomial. So let's do the slided divide method. So for the slided divide method, we will slide the A term over to the C term, multiply them, and then rewrite it. We have x squared plus 23x plus 42. Identify your new A, B, and C terms. So our new A is 1, our B is the same, still 23, and our new C term is 42. So we can write our product, which is 42, sum is 23. We'll find two factors that multiply to give you 42 and add to give you 23. If you need to, you could do a T-chart to write your factor pairs and your sums. So our factor pairs is 1 and 42, 2 and 21, 3 and 14, 4 doesn't work, 5 doesn't work. 6 and 7. And we already have 7, so we're done listing the factor pairs. These are going to be added together because you want the same sign because our product is a positive. We want them to be positive signs because our sum is also positive. So our sums are 43, that doesn't work. 23, that one does work. 17, no, and then 13. So the factors that we will use is 21 and 2. So then we'll write out the factors. We have x plus 21 times x plus 2. But for the slide and divide method, we're not completely done. We will also divide by the original a. So we divide each of those factors we just found by our original a. Simplify the fractions as much as possible. So we have x plus 7 and x. This is already reduced, but we don't want a denominator inside of our factors, so we slide it to the front. So we have 3x plus 2. And this is our factored form. So these would be your algebraic steps, and these are your verbal steps. Number 5. Factor 5x to the 4th power minus 35x to the 2nd power plus x squared minus 7. The first thing we'll look for is a greatest common factor. There is no greatest common factor here besides 1, so we can skip that step. The next step, we're going to select a method of factoring. So if you look back up here, it's not x factor because for one there's 4 terms here, there's not just 3. And a is not 1. It's not formula because it's not binomial. We're not doing slide divide because this is not a quadratic. This is a quartic. Has a degree of 4. Let's see about grouping. Grouping is for polynomials with 4 terms. Well, there's 4 terms here, so let's try that one. So we'll group 5x to the 4th power minus 35x squared. And then we'll put a plus sign and then group the other 2 terms. X squared minus 7. When you're doing grouping, always remember to have a plus sign in between the 2 groups. If there's a negative sign, you need to make sure there's a positive sign as well. From there, you want to factor out the GCF out of each pair. So the greatest common factor of 5 and 35 is 5. And the greatest common factor of x to the 4th and x squared is x squared. To get what goes on the inside, divide each term by 5x squared. 5x to the 4th divided by 5x squared is x to the 2nd power. Negative 35x squared divided by 5x squared is a minus 7. The only GCF for these two is 1. So just put a 1 out there. And we'll rewrite what's already inside. From there, they each share a common factor. So we can factor that out. And then what's left inside is 5x squared plus 1. And that would be our factored form. Now from there, they might want you to go further than that and find the difference of squares. Now for this one, our squares are not perfect here, so we don't have to move on from there unless it specifically wanted the irrational factors. If it did, you could further factor this down into this. Now, since it didn't ask for the non-factorable factors, you could just keep it at this. But if it did, this would be your final solution, your final factored form. Number 6. Factor 64x squared minus 49. Now this one will have perfect squares. So you want to determine which factoring method we'll use. This is binomials, and they are perfect squares, so we'll use the difference of squares formula. And I'll write that right here. So our difference of squares formula is a squared minus b squared equals a minus b times a plus b. Now these are not the a and b that are from the other examples. It's not just the coefficient. It's talking about the whole term. So we want to identify a squared, and that's our first term, 64x squared. And we want to solve to get a. To do that, we want to take the square root of each side. So a is going to equal plus or minus 8x. We want to find that for the formula. And then we'll do the same thing with our b term. Our b squared is 49. And we'll take the square root of each side. So b equals plus or minus 7. Wait, this one doesn't have a plus or minus sign since there's an x. This one does have a plus or minus sign since we only took the square root of a constant. So from there we'll plug it into the formula. So we have a minus b, so that'd be 8x minus 7, and then we have a plus b, 8x plus 7. And that is our factored form. Number 7. Factor x cubed minus 125. This is another one where you want to use one of the formulas. These are both perfect cubes, so we'll use the difference of cubes formula. So from there we want to identify our a cubed and solve for a, and then our b cubed and solve for b. A cubed is x to the third power. To solve for this, to get rid of the cube, you want to take the cube root of each side. So you have a equals x. Our b cubed is 125. We'll take the third root from each side, and you get b equals 5. From there you'll just plug it into the formula. So we have x minus b, or a minus b, which would be x minus 5, and then times a squared, which would be x squared, times ab, which would be plus 5x, plus b squared, which would be plus 25. And that would be your factored form. Number 8. factor negative 12x cubed plus 15x. Now with this one we have to find the GCF. They both can divide by 3, so we have negative 4x cubed plus 5x. We want that first number to be positive, so let's divide out negative 1 as well. So we have 4x cubed minus 5x. They both share an x, so you can also divide out one of the x's. So there you have 4x squared minus 5. There's nothing else we could factor out, so your GCF is negative 3x. So your factored form would be negative 3x times 4x squared minus 5. And we can't factor this any further to get rational factors, so this would be it. Number 9. Given 6x squared plus 11x minus 35 equals 0, if R1 and R2 are two solutions and R2 is greater than R1, what is the value of R2 minus R1? So the first thing we want to do is find what is R1 and R2, the roots. So it looks like a method we can use for factoring this. There's no GCF other than 1, so let's use the slide and divide method. So our original A is 6. So let's go ahead and slide it over to the C, go from there. Also, the reason why we could go straight into factoring is because it's already in standard form. We have our A, B, and C terms on one side and 0 on the other. So next you want to identify A, B, and C. Your new A is 1, your B coefficient is negative 11, and your constant C is negative 210. Draw your X, your product is negative 210, and your sum is negative 11. Find two numbers that multiply to give you negative 210 and add to give you negative 11. So you have 1 and negative 210, 2 and 105, 3 and 70, 5 and 42, 6 and 35, 7 and 30, 10 and negative 21, and then 14 and negative 15. So let's find the sums of each of these factor pairs to see which one gives us negative 11. So it looks like our second to last factor pair is the one that works. So we have negative 21 and 10. So write our factors. So we have x minus 21 and x plus 10. Now we also need to divide by our original a's, which is 6. And this equals 0. Simplify the fractions as much as you can. So simplify the first one to get negative 7 over 2. And the second one gives you x plus 5 over 3. From here, we'll set each one equal to 0 using the zero property rule to solve for the x's. So we have x minus 7 halves equals 0 and x plus 5/3 equals 0. Add 7 halves to both sides. So you get x equals 7 halves, and then you subtract 5/3 from each side of the other equation. You get x equals negative 5/3. Now from there, it says that we have R1 and R2, and R2 is going to be bigger than R1. So R2 must be this one, and then R1 is this one. So now evaluate 7 halves minus negative 5/3. Now for 1, these two negatives will multiply to give you a positive. And then from there, we want to make sure they have the same denominator. So we can multiply these by the unity fraction 3 over 3. And we can multiply the second fraction by the unity fraction 2 over 2. So then you have 21 plus 10 all over 6. So that's 31 over 6. That would be your answer. You can't simplify it any more than that. Number 10. What are the solutions to the parabolic equation x plus 9 times x minus 3 equals 0? This was really easy. It's already factored. You just use the zero product property to solve for each root. So we have x plus 9 equals 0, or x minus 3 equals 0. Solve for x for both of these. Subtract 9, add 3. So then you get x equals negative 9 and x equals 3. So your zeros are negative 9 and 3. Those are your solutions. Number 11. Given 4w squared plus bw plus 49, what b value would make this a perfect square trinomial? So we have our product AC, which is 49 times 4, that's 196. These two factors have to be the same, and this is positive. The square root of 196 is 14. So we have these numbers. These are our givens, basically. So this is AC. This is the square root of AC. It is also the square root of AC in this case, because it's perfect square. Now, to get B, we just add these two numbers together. 14 plus 14 is 28. So B equals a positive 28. Number 12. The volume of a rectangular prism is given by the function v of x equals 36x cubed plus 291x squared plus 24x. Explain how to find the dimensions and state the dimensions. So the first thing you want to do is find the greatest common factor. They all share an x, so we could divide out x. The smallest x has an exponent of 1. So we have 36x squared plus 291x plus 24. Now, to find a number that all three of these are divisible by, let's review our divisibility rules from elementary school. These are the divisibility rules that you can find from the fractions tomb notes that you will see next semester when we do our rational functions. So let's go through these. The last digit is divisible. It's a 0, 2, 4, 6, or 8. Now, these two work, but this middle term does not divide by 2 because it's an odd number. So it can't be divisible by 2. 3. Some of the digits are divisible. Well, 6 plus 3 is 9. 9 divides by 3. That works. 9 plus 1 plus 2 is 12. 12 does divide by 3. 4 plus 2 is 6. 6 divides by 3. So that means that these numbers are divisible by 3. So we're going to divide each term by 3. So we have 12x squared plus 97x plus 8. Okay, from there, 97 is a prime number, so this would just be the GCF here, 3x. So we can rewrite this as 3x times 12x squared plus 97x plus 8. So we found one dimension so far, the 3x. That's one of the dimensions of the volume of this rectangular prism. To find the other two dimensions, we have to factor this trinomial. A is at 1, so let's use the slided divide method. So we have A equals 12, B equals 97, and C equals 8. So we will find two numbers that multiply to give you 12 times 8, which is 96, and they add to give you B, 97. This one looks really easy to see because we just could do 96 times 1. 96 times 1 is 96, and 96 plus 1 is 97. Of course, you could always write out one of those T-charts to write your factors and your sums. So from there, we'll write our factors, x plus 96 and times x plus 1. We'll divide by our original A value, which was 12, and then simplify the fractions. 96 divided by 12 is 8. So x plus 8, and then we'll slide this 12 to the front because it's already simplified. 12x plus 1. And then we'll write the 3x in the front. So these are your dimensions. So we could say like this is the length, this is the width, this is the height. Now it doesn't matter which one's L, which one's H, and which one's W. We'll just label it that though. So once we get there, we need to go back in and explain the process verbally. So we factored out the greatest common factor using the upside down cake method. You could also use factor trees to do this. When we're pulling out the 3, we use the divisibility rules to help determine what numbers we can actually pull out. Step 3, we chose a factor method to factor this remaining trinomial inside. We used the slide divide method. Identify A, B, and C, and then for slide divide, you divide by your A value at the end and slide it to the front of the X, to the front of the variable. And then the last step, we just label each of our factors with one of the dimensions: length, width, and height. Number 13. Factor the perfect square trinomial x squared minus 26x plus 169. A is just 1 here, and we have B is negative 26, and C is 169. Now this is a perfect square, so basically the square root of 169 is 13. And we want to get negative 26, so it's going to be negative 13s. Negative 13 times negative 13 is a positive 169, and negative 13 plus negative 13 is negative 26. So we just have x minus 13 squared. The multiplicity is 2 because it's the factors repeated twice. And that's it. Solve. So number 14, solve x plus 1 squared minus 5 equals 20. You will explain your answer both algebraically and verbally. So the first thing we want to do is just write out our given formula, our given equation. From there, we'll add 5 to each expression. And then rewrite it. We have x plus 1 squared equals 25. To get rid of a square, we have to take the square root of each side. Whenever we square root a constant, we put plus or minus in front of it. So we have x plus 1 equals plus or minus 5. Just like what we saw for absolute values, the first 6 weeks we'll do 2 equations, a positive one and a negative equation. So we have x plus 1 equals 5, or x plus 1 equals negative 5. Solve for x for both equations. So we have x equals 4, or subtract 1, x equals negative 6. So we have our 2 solutions. We have negative 6 and positive 4. Now we don't have to check for extraneous here because the only x value we have is squared. And if you square something, it'll always end up being positive. So this is our answer. Number 15. Use U-substitution to factor 4x to the 4th power minus 8x squared minus 21. First, we want to identify what u is going to equal. We're going to let u equal x squared. And then we'll rewrite the expression in terms of u. Let's do the Xbox method on this one since we haven't on any of the others from this review. Identify A, B, and C. We have 4, B is negative 8, and C is negative 21. So we draw our X. Our product is 4 times negative 21. negative 84, or b is negative 8. So the factor pair that works here is negative 14, positive 6. So from here we could draw a box. The first box will have the first term, 4u squared. The last box will have the last term, the constant, negative 21. And the two middle boxes will be the factors we found, plus 6x and minus 14x, or u in this case. From here, we'll factor out the GCF from each row and each column. The GCF of these two terms is 2u. The GCF of these two terms is negative 7. The GCF of these two terms right here is 2u. And the GCF of these last two is positive 3. We can always check by multiplying them back in. 2u times 2u is 4u squared, and so on. So these are our factors. We have 2u plus 3 and 2u minus 7. Now I wanted it in terms of x, so you'll unsubstitute, and now wherever you see u, you'll put x squared instead. So we have 2x squared plus 3 times 2x squared minus 7. And that is our factored form. Number 16. Factor the polynomial by graphing. 3x cubed minus 10x squared minus 27x plus 10. If you try to do this one by grouping, it won't work very well. So another method you could always use is the graphing method. So you go to desmos.com/calculator and graph this expression right here. So once we've graphed our expression and we graph the picture, we'll find the three x-intercepts. We have negative 2, we have 0.33333 repeated, and we have 5. So from there we write out our zeros. We have negative 2, 0.3 repeated, and 5. Now we want to change that repeated decimal into a fraction. So we have negative 2, 1/3, and 5. 3 repeated would just be, it would be 3/9, and that reduces to 1/3. Whenever you get a decimal that repeats, just put the number over 9. So this will be 3/9, that reduces to 1/3. If you want more practice on those repeating decimals, let me know. Send me a message, I'll remind. So from there, we can write out our factors. So we have x minus 2, x, well, not minus 2. We change it to a positive. Wherever we go from zeros to factors, we change the sign. So it'll be x plus 2, x minus 1/3, and x minus 5. We will slide the denominator to the front. So our factored form is x plus 2 times 3x minus 1 times x minus 5. Has 3 distinct factors there. And that would be our answer. Number 17. Factor the trinomial. Hint, your factors will be irrational numbers. X squared plus 4x minus 1. Now the only method that we talk about irrational numbers or imaginary numbers is the low method. So we'll do the low method here. So we want to find the sum and the product. So our sum is 4, our product is negative 1. Here's our formula. A is 1, B is 4, and C is negative 1. So we'll plug it into the formula. Negative b over 2a, in this case, would be negative 4 over 2 times 1. That would be negative 2. So we plug it into the formula. We have negative 2 minus u times negative 2 plus u. And that's going to equal c over a, which is negative 1. This is a difference of two squares, so we have 4 minus u equals negative 1. So we want to move all the terms to one side and all the variables to the other. So we have 5 equals u. There should be a squared on there. From there, we'll take the square root of each side, put a plus or a minus there. U equals positive or negative square root of 5. Plug it back into the formula. You have negative 2 minus the square root of 5, and we have negative 2 plus the square root of 5. Those are our zeros. Now to get the factors, we just put x and then we change the sign. So x plus 2 plus the square root of 5 times x plus 2 minus the square root of 5. And those would be our irrational factors. You only need to find irrational factors if it says to do so, or if it says to find the other zeros. Number 18. Factor the trinomial. Hint, your factors will be imaginary numbers. X squared plus 6x plus 13. The only method that we talked about that has imaginary numbers is the low method, so we'll use the low method again. So we have our formula, and we will find our sum, product, ABC, and our negative b over 2a. So our sum is 6, that's our b value. Our product is 13. A is 1, B is 6, C is 13. So negative b over 2a would be negative 6 over 2 times 1. That equals negative 3. Plug it into the formula. You have negative 3 minus u times negative 3 plus u equals c over a, which would just be 13. This is a difference of two squares, so you have 9 minus u squared equals 13. Move all the terms to one side, or you move all the constants to one side, all the variables to the other. So we have 9 minus 13 equals u squared. Combine the like terms. we have negative 4 equals u squared. To get rid of a square, take the square root of each side. Put a plus or minus in front of it. The square root of 4 is 2, but we have a negative, so we have to also put the letter I. From there, we'll plug it back in to get our zeros. We have negative 3 plus 2i and negative 3 minus 2i. That's our zeros. To get our factors, we just change the sign. So we have parentheses x plus 3 minus 2i times x plus 3 plus 2i. And that would be your factors. Usually when it has imaginary numbers or irrational numbers, they only want you to find the zeros. So you usually can stop once you get the 2 zeros. In this case, we want the factors as well, though. Look back through this video if you need more help on going through these specific problems. Good luck on your test next class.